Alright, so this is the section 6.3 lesson video. So this is our last section for chapter 6. So we're going to focus on periodic trends. Now for periodic trends, we're just going to kind of hit the surface. So we're not going to discuss every possible one that there is, and we're not going to dive really deeply into depth. Like we're not going to go into shielding of electrons and effective nuclear charge and things like that. So we're just going to kind of brush the surface. If you need more information on that, that would be in the honors or AP videos for this section. So, first thing is atomic radius. We're going to discuss 4 trends in this class, and so the first one is atomic radius. So, atomic radius is the radius of an atom. So, what do I mean when I say we're going to discuss the trends of atomic radius? Well, think about a clothing trend. In a clothing trend, a lot of people are doing it, but not everybody. Like, for example, there's a trend of wearing leggings right now. So a lot of girls wear leggings, but not everybody is. So it's just a trend that a lot of people follow. So periodic trends are the same way. A lot of elements follow them, but there's always some exceptions or outliers. So in general, atomic radius increases as you move down a group and decreases as you move across a period. Now, if you're in class with me, when I teach you trends, I put up all this fake periodic table of elements with all the Bohr's models of different ones on there for elements and ions. Unfortunately, I can't really get all of that into the video screen because it takes up the whole board. So hopefully you have a periodic table that you can look at, and you might just have to kind of envision what I'm talking about. So this lesson is actually much better if you actually see it in class. All right, so as we go down a group, you can physically see that atoms are getting larger, the radius is getting larger. And as you move across, it actually decreases. And the across is what people tend to struggle with. Everybody realizes as you go down, you get a larger and larger energy level. It's the across that is the problem. Okay, so what I want you to notice is that on each trend, the reasoning behind it is the same for all of them. You're going to hear me say the same thing over and over and over again. Okay, so it seems like a lot of information, but if you just focus on the fact that it's the same thing over and over again, it's really not that much. Alright, so why does this happen? Well, the atomic radius increases going down a group because larger energy levels are added. So in the first row, you only have one energy level. If you move down to the second row, now you have a second one. If you move down to the third one, now you have a third one. So it's going to get bigger as you go down. Now, it's the across that's a little bit tricky because you think, well, you're adding a proton and an electron each time. Why isn't it getting bigger? Well, the atomic radius decreases going across a period because electrons are added to the same energy level. So the energy level itself is not getting any bigger. So you may think, well, then why doesn't it stay the same? But protons are added to the nucleus, which pull the electrons in closer. Okay, so what happens is as you move across, the nucleus gets stronger. Think of it as like a magnet. The nucleus is pulling those electrons like a magnet to itself. And so as the nucleus gets stronger, it can pull them in closer. Now the reason that doesn't happen going down, because you may think, well, going down the nucleus gets stronger, and it does, but the electrons are in a whole nother energy level that's gotten bigger and further from the nucleus. Okay, so these are the reasons for all the trends. As you go down, you just need to think energy levels are getting bigger. As you go across, you need to think the nucleus is getting stronger, and that will help you explain all of the trends. So now let's talk about ions a little bit. So this is kind of our first real brush with ions. We'll talk about them a lot more in chapter 7. So an ion is an atom with a charge. So how does that happen? Well, an atom has a charge when it gains or loses electrons. So an anion is negative, and so that means it's gained electrons. And that gets tricky because you want to think it's negative, so you want to think it has subtracted or lost electrons. Remember, a negative is not the same as a subtraction sign. All right, it's negative because it has extra negatives or extra electrons. And then a cation is positive, and so it has lost negatives or electrons. Sometimes if you'll call electrons negatives in your mind, then the whole positive, negative ions will make a little bit more sense. All right, so what I always tell my students is anion has an N, so it's negative. Cation has a T, which looks like a plus sign, so it's positive. All right, so a negative ion has extra negatives or has gained electrons, and a positive ion has less negatives or has lost electrons. So you can tell the charge that an element's going to have based on which group it's in on the periodic table, except for transition metals. or the lanthanides and actinides. All right, so you may want to get your periodic table out and label the charges across the top. So group 1, everything in group 1 forms a positive 1 charge. In group 2, they form a positive 2 charge. Remember, we skip the transition metals because they can have multiple charges, but they are all positive. So sometimes I'll just kind of draw a little parentheses there and then put a positive. In group 13, they have a positive 3 charge. In group 14, it can be positive or negative 4. Group 15 is a negative 3 charge. Group 16 is a negative 2 charge. Group 17 is a negative 1 charge. And group 18 has a 0 charge. Now again, if you were actually in class and I had my whole periodic table out, this would take forever because I literally show you why this happens. Again, in this video, there's not that much time and I just don't have anybody who's holding the camera. If somebody's holding the camera, they could kind of go to the different parts of the board. So my video is not really going to explain why those are the charges. You just kind of have to accept them from the video. All right, so our next trend deals with ionization energy. So now we know what an ion is. It's an atom that has lost or gained electrons. So ionization energy is the energy needed to remove an electron from an atom. So it has all its electrons, we're trying to take one away. How much energy would that take? So in general, ionization energy decreases as you move down a group and increases as you move across a period. Okay, so in other words, it's the opposite of what atomic radius did. Atomic radius increased going down a group and decreased across a period. Ionization energy decreases as you move down a group and increases across a period. So why does that happen? Well, the explanation is the same as it was for atomic radius. Ionization energy decreases as you move down a group because larger energy levels are added, which are farther from the nucleus. Since the electrons are far from the nucleus, it takes less energy to remove. Think about magnets. When they're really close, you can feel the attraction or repulsion. When they're far away, it's still there, but you can't feel it as much, so it's easier to pull that magnet away. The same thing happens with electrons. So as they get in the bigger energy levels, it takes less energy to snatch one from that nucleus. Ionization energy increases as you move across a period because remember, across a period, that nucleus gets stronger. And so it takes more energy to remove an electron from a stronger nucleus. All right, so see the explanations are the same for the going down and across. Remember, go down, focus on larger energy levels. Going across, focus on stronger nucleus. So the next one we're going to discuss is ionic radius. Okay, so we already did atomic radius. Ionic radius is the radius of an ion. Cations, remember those are positive, which means they've lost electrons. Since they've lost electrons, they are smaller than the parent atom. Okay, so for example, the brownish or tannish circle you see was the original radius of lithium. Once it lost an electron, now it's much smaller. You can see the red circle. Same thing happens here. Here's potassium. It was this big. It lost an electron, and now it's this big. So our positive ones, you can see they get smaller each time. Anions, which have gained electrons, are larger than the parent atom. So here we have sulfur. Its original size was this tannish circle, but once it gained 2 electrons, now it's gotten larger. So you can see all our anions are getting bigger. So a cation loses electrons, so it becomes smaller. An anion gains electrons, so it becomes larger. Because what happens is when you gain those electrons, if you don't gain any protons, the electrons have this electron-electron repulsion that causes them to spread out. Remember, electrons don't like each other. They're all negative. So they repel one another. So in general, ionic size increases as you move down a group because larger energy levels are added. It doesn't matter if you're gaining or losing electrons. In ions, as you move down, you're still acquiring new energy levels each time. Whether you're gaining or losing from those energy levels, they're still there. All right, so ionic size generally decreases across the cations, then it increases as you move to the anions, and as you move across the anions, size decreases again. This is due to the increased strength of the nucleus and the loss or gain of electrons. Now, I don't focus on making you explain the across for ionic radius in my class. Other teachers may. I think it's more important that you know that it increases going down due to those larger energy levels, and you know that cations get smaller and anions get larger than the parent atom. Because the across one for ionic radius is a little weird. All right, so our next trend is electronegativity. So people get electronegativity and ionization energy kind of mixed up sometimes. Ionization energy is energy needed to remove an electron. Electronegativity is the ability to attract more electrons. So how much ability does it have to attract a new electron to itself? So in general, electronegativity decreases as you move down a group and increases as you move across a period. So one year I had some students trying to remember the trends, and so they came up with the idea that if it has radius in it, so atomic radius, ionic radius, then it increases going down and decreases going across, even though ionic radius has that weird decrease, increase, decreasing. And then they said if it doesn't have radius, so ionization energy and electronegativity, it's the opposite. So they said it decreases going down and increases going across. And so if you need that to kind of help you remember that would be fine. So why does this happen? Well, the same reason as with all the other ones. So electronegativity decreases as you move down a group because larger energy levels are added that are farther from the nucleus, so the atom cannot attract electrons as well. Remember, it's like a magnet. If I have two magnets close together, they can attract each other easily. If they're further apart, it's harder to attract one another. All right, and then electronegativity increases as you move across a period because the nucleus is stronger and can attract more electrons. All right, so the important thing to remember is when you're talking about going down a group, you need to focus on what would happen with larger energy levels as we get farther from the nucleus. When you're going across a period or a row, you need to focus on what would happen if that nucleus is getting stronger each time, because that's what causes the trends to happen. So here's just kind of a summary. Some of the other trends you could learn if you're in a different classes. You could talk about the metallic nature, you can talk about electron affinity, things like that. So how does atomic size change within groups and across periods? Okay, so when you're going down a group, atomic size increases. And when you're going across a period, it decreases. When do ions form? Ions form when atoms gain or lose electrons. When atoms gain or lose electrons. Number 3, what happens to first ionization energy within groups and across periods? All right, well, ionization energy, when you go down a group, decreases because the energy needed to pull an electron away when it's farther from the nucleus is less. And across periods, it increases. It says, compare the size of ions to the size of the atoms from which they form. So cations are positive, which means they have lost electrons, so they are smaller than the parent atom. Anions are negative, which means they gain electrons, so they are larger than the parent atom. So number 5. How does electronegativity vary within groups and across periods? Again, if you remember, ionization energy and electronegativity, they both follow the same trend, and then atomic radius and ionic radius follow the same trend. So electronegativity decreases as you go down a group and increases as you go across a period. All right, and so those two trends are the same. And then, like I said, atomic radius and ionic radius, they both increase going down, but that ionic radius gets a little weird going across. All right, so arrange these elements in order of decreasing atomic size: sulfur, chlorine, aluminum, and sodium. Does your arrangement demonstrate a periodic trend or a group trend? So this is where you'll want to have your periodic table out. So we're looking at sulfur, which is S, chlorine, which is Cl, aluminum, which is Al, and sodium, which is Na. And so if you look on your periodic table, it's kind of like this arrangement. We're kind of in the third energy level or the third row. And so sodium is the first element. And so then if you look across some, you'll have aluminum kind of over here. And then a little ways over, we have sulfur, and then we have chlorine. So this is kind of the order of them on your periodic table. Of course, they're spaced out and have some other stuff in between them. All right, so it says, arrange these elements in order of decreasing atomic size. Well, as you go across, size does decrease. So this is decreasing size. Then it says, does it demonstrate a periodic trend or a group trend? Well, what is a row called? Is it a group or a period? Well, a group is a column up and down. So this would be a periodic trend because they are all in the same row or period. All right, and so number 7, it says which element, this should say in each pair has the larger first ionization energy. So let's just write our trend over here real quick so we can use it. All right, so ionization energy, we'll just pretend like this is the periodic table. I know it's not a perfect rectangle. So as we go down, ionization energy decreases, and as we go across, it increases. Sometimes it helps to give yourself like a little map to go with. All right, so let's figure out where everybody is. So this is my ionization energy. All right, so we have sodium and potassium. So if you look on the periodic table, sodium is kind of right here, and potassium is right under it. So it says which has the larger first ionization energy? Well, as you go down, it decreases. So who has the larger one? Sodium does. All right, so now let's look at our next two. So we have magnesium and phosphorus. So if you look on your periodic table, magnesium's kind of right here, and phosphorus is in the same period, but it's down to the right of the periodic table. So it says which element has larger first ionization energy? Well, what does ionization energy do as you move across? It increases. So who has the larger one? Phosphorus does. All right, and so see, a lot of you get really good at memorizing the trends and even being able to explain the trends. Like I don't know that you fully actually understand what you're saying, but you get good at memorizing my explanation. But these are the ones that a lot of you struggle with, is then if I give you multiple elements to compare, it falls apart because you can't memorize all of that. So for the periodic table, it really helps if you actually understand the stuff and not just memorize it. And actually for this whole chapter, all of chapter 6, the more you understand about the periodic table, the easier the whole rest of this class is. Like if you can't figure out charges and things like that later in the chapters, it's going to get really hard really fast. So it's not just about memorization, it's about that understanding of everything. So hopefully though this chapter wasn't too bad, and we'll move on to chapter 7 and learn a little bit more about ions.